Okay, so in the last session, we have completed writing the queries for those tables that we were creating ourselves. Now, what if we want to add some large data set to the Databricks, which could be in some other format like .csv, .excel, .parquet, or something like that. So, how can we do so? So, we can start by adding or uploading the data set to the Databricks. So, let's move forward with that. First of all, this is the Databricks workspace where we can go to new, then to add or upload data. After that, we can click on create or modify table if we want to select our data set from our own device. Other than that, we can also go for OneDrive, Google Drive, Jira, GitHub, wheresoever we want to extract the data from. After clicking on Create or Modify Table, we can browse the dataset from our own device and can select the required dataset. So this is the dataset that I have selected for which I want to write the queries, for which we have to select the catalog in which we will be creating our table. Under this, select the schema and can give the appropriate name to our table name and can create the table. So the view of the table can be seen by writing a simple syntax, select star from name of the schema that is demo1 dot name of the table that is spike underscore data underscore 22 underscore snappy. So this is the view of our data set. Now moving forward, so let's start with the general structure that we will be using for writing the queries that is select from where. So we will be selecting either all or distinct expressions from table name where that will specify a particular condition. So this query will select rows from the source table name and output the result in the table form, where expression 1, expression 2 can be a column or a expression of functions and fields. And column 1 and column 2 are the corresponding column names in the output table. This distinct will eliminate duplication in the output, while all will keep all the duplicated rows. Now let's move forward with some examples. Let's start with select statement recap. So let us suppose I want to extract some particular columns, not all the columns from that table, with the column name of my own. So let's start by extracting ride ID, start let, and start long from that table where the name of start let should be start latitude and start long should be start longitude. So we can write a simple syntax, select ride ID, start let as start latitude, which is we are aliasing the column name with the name that we want to give to this column start underscore let, similarly with start underscore long, and it will give the desired result. Now we can also obtain this similar result by avoid writing the keyword as, but it is suggested to use the keyword as. So you can also write select write ID, start let. Instead of S, you can just use white spaces and start latitude, start long, space start longitude from name of the table. So the results will be exactly same. Now, as you can see that all the column names are having underscore between them, which means that there are no spaces between the inside the name of the column. So the white spaces are not allowed. But we can write the column names with white spaces by making use of quotation marks as follow. Let us suppose I want to write underscore as right space ID. So I have to enclose them inside the quotation mark as in the given example. For start latitude and for start longitude, we can do same. And these will be the output that is obtained from this particular syntax. Now let's move forward with some other example for the select statement. What we can do is we can also alias the table name as T or something else. This is mainly done when the table name is very large Now, in this case, we have to write it once, but sometimes we need to write it multiple times. So it is easy if we alias our table name with something short. So here I have alias my table name with T, and in front I can write select T dot column name, T dot second column name, and so on for multiple columns. Similarly, we can extract all the columns by just writing T dot star instead of specifying all the column names one by one. Now, this was for all the records, but what if I just want to select the unique collection of records, a unique combination of records, so we can make use of distinct statement. We can simply write select distinct column names that we want to extract from name of the table. So it will give unique combination of start session ID and end session ID. And to get unique combination of all the columns, we can write select distinct star from table name. Now moving forward for filtering the records based on multiple conditions, we can make use of conditional statements or and not between and so on. So let's start with the conditional operators. So how we can filter records by using where clause on the basis of conditional operator. Let us suppose I want to extract data from my record in such a way that it contains a particular value for station start ID. So I am extracting the records where the start station ID is HB103. So I can write select star, which means select all the columns from this table where start station ID is HB103. Since HB103 is a string column, so I had to enclose them inside the quotes. Similar syntax will be for timestamp column, right? So here, this value is a date timestamp, is of date timestamp data type. So we had to enclose this inside the quotation mark also. Otherwise, the syntax is exactly same. And for the numerical columns also, the syntax will remain same, but there is no need of the quotation marks. As we can see here, the start latitude is equal to the numerical value that we want to give. Otherwise, the syntax is exactly same. Now, moving forward for conditional operators with something other than equal to, like greater than equal to or not equal to or all those. So here we have written select all the values from this table where started at contains a date which is greater than equal to this particular date timestamp, which means that it will return all the records which have a value of date which comes after this particular date timestamp. Similarly, the syntax which states that select all the values from this table where member casual is not equal to member. So this will output all the records where the value of member casual can be anything other than the member. Moving forward with the OR operator. So OR operator is used when we want to satisfy either one of the conditions. Let us suppose we are using it for two conditions, condition 1 and condition 2. So in case if condition 1 is satisfied or condition 2 is satisfied or both of them are satisfied, then it will return the output. Let's see an example. Here we are selecting all the columns from the table where either member casual is casual or start session ID is JC014 or both of them are satisfied. Now we will run the same query but with AND operator instead of OR. So it will return those records only which follows both the conditions together. In case if one of the condition is true, then the record will not be fetched, but the record will be fetched only when both the conditions are true, as can be seen in the output as well. So both the conditions are satisfied for all the records. All the stations that ID are JC0114 and all the member casuals are casual. Let's move forward with not. So not is used when we want to satisfy something like that the output could be anything other than this particular condition. As we can see here, it is written where not member casual is equal to casual. So it will give any value for the member casual other than the casual. So this column will contain anything other than the casual. Now moving forward with between. So between is for the values which will lie between the two conditions. So it will fetch all the records from this table where the column started at will contain any date which is between this first one and the second one. That is from 6th to 7th. Now moving forward with an operator. So an operator is used when we have to specify some particular values that either the value could be this or this or this. Let's see an example. Now here we have written that we have to select all the column where the start station ID can be JC23, JC109 or J393. Now this column that is start station ID will contain either these three values that are JC023, JC109 or JC93. No other value can be fetched. Moving forward with like operator. So for like operator, first of all, we should understand the concept of two special characters which are percentage and underscore. So in SQL, percentage is used for any number of characters and one underscore is used for one particular character. For example, in this syntax, we are writing from select all the column from this particular table where station name is like percent %SG percent. So what this percent %SG percent means, there should be a string like which contains SG with any number of characters before SG or any number of characters after SG. There could be no characters as well. What it means is that there should be SG either in the start or somewhere in between or at the last. As can be seen in the following example as well, all the records that contain SG anywhere in them are fetched. Now moving forward with another query that is select star from this table where station name is like this. So there are 8 underscore in this query. So it means that the length of the string can be 8, which may or may not contain the white spaces. So one underscore signifies one character. Okay, what if in case we are writing 7 underscores and it lasts A? So let's imagine a query where station underscore name like 7 underscores and A within A. So what does it mean is there should be A at the last which can contain 7 characters. Before that, those 7 characters may or may not have white spaces. Now moving forward with deleting the records, so we can simply delete the records by writing delete from name of the table and can specify a particular condition with where clause. And if we do not specify any condition or any predicate is specified, then it will delete all the data from the table temp station data as done in this query. Now there are so many inbuilt functions like string functions, numerical function, date, timestamp functions, and so on in SQL. So we will go through them one by one. Let's start with the string functions. So there are many string functions like upper function, lower function, init cap, length function, right function, left function, concat. So what are they actually? So let's start with the upper function. So upper function is used to convert a string value or a string character in all upper cases. Let's see an example. Here we are writing upper member casual. So it will return the same values which are inside member underscore casual, but all characters will be in uppercase, as in the following example. Now, as you can see that the name of the column will automatically be upper member underscore casual. But what if we want to give it a particular name of our own choice? So then we can use the aliasing by writing as keyword along with the column name that we want it to give. Similarly, we can make use of lower function. So lower is used to convert a string with all the characters in lowercase, and init cap is a function which is used to convert a string in such a way that first character is in capitalized format, that is, first character is in uppercase, and all other characters are in lowercase. Let's see an example. For lower, we have written lower ride ID, so it will give the results of ride ID, but all the characters will be in lowercase, as can be seen here. Also, we could have made use of as keyword for giving it a column name of our own choice. Moving forward with init cap, here we have written init cap member casual, so it will return all the values of the member casual in capitalized format. Here also we could have made use of aliasing. Moving forward with right or left functions. So what are right and left functions? They will give particular characters. Let's start with right function. So right function will give particular number of characters from right and the number that you will specify. Same as with the left function. Left function will give particular number of characters from left which are specified by the users. Let's understand it with an example. As here it is written, write member underscore casual comma 3. So it will return all the values that contain first three characters and member underscore casual. Okay. And for left member under casual comma 3 will return last three characters or the three characters from the left that are the first three characters like MEM for member and the right three characters are BER. Moving forward with the length and concatenate function. So length will give a numerical value that will be the actual length of the string. And concatenation function or concat function is used to concatenate two different columns with a specified character or white spaces. So let's see an example. For length member underscore casual, it will give the length of the values which are inside the column member underscore casual. So here the answer is 6 as the length of member as well as casual, which can be the values inside this column is 6. And for the concat function here, we have concatenated two columns, start station ID and end station ID, with a hyphen between them. As you can see, here is the start station ID and here is the end station ID, which is concatenated here with a hyphen between them. Then are the numerical functions. So for the numerical functions, first we will create a table which will contain the numerical data type. So here we have created a table inside the default schema named as numerical function demo with two columns named as column 1 and column 2 with data type double. And these are the four values which are inside column 1 and column 2. Now let's start with arithmetic operators. So since this table contains two columns, column 1 and column 2, we will try to create other columns by adding these two columns, subtracting these two columns, multiplying them and dividing them. So for that, we can simply write select column 1, column 2, if we want these columns to be as such. And then column 1 plus column 2 will give the addition of the values inside these two columns. Column 1 minus column 2 will give the difference of the values inside those two columns. This will give column 1 into column 2 will give the multiplications of values inside column 1 and column 2, and column 1 upon column 2 will give the division of values inside column 1 and column 2. There are some other functions like absolute and round off. So absolute, as in this example, will give the positive values for the values which are inside column 1. And the round off function will round off the values to a decimal place that we will specify. As in this case, we have written round column 1 upon column 2, comma 1, which means that it will round off the values after dividing the values of column 1 and column 2 up to one decimal place. Now let's move forward with date and timestamp functions. So there are different functions inside it, like date_def, which is used to differentiate two dates either in hours, minutes, or seconds. So let's go through an example first. Here as it is written, date_def minute, comma, started at, comma, ended at. So started at and ended at are two columns which are in date time format, for which we have calculated a difference, and that difference will be in minutes. And the name of that column will be duration minutes. Then is the date format, which is used to change the format of the date or to apply a format of our own choice. As in this example, date format started at MMYY. So it will convert the date format of that started at column into this particular format, which is month dash year. And similarly here, it will change the date format in MMMYY as done in this following output. Now we can also fetch current date or current time using date and timestamp functions. So to get current date, we can simply write select current underscore date parenthesis, and to get current timestamp, we can simply write select current underscore timestamp parenthesis. And to get them together, we can write this syntax together. Now, as we have, if we create a table in date and timestamp format, as in the following example, here a table is created named as date conversion demo, where there are two columns, column 1 and column 2, where data type as date and timestamp respectively. And we try to add the values of our own choice. As you can see that this is a date and this is a date time zone, but it is giving an error because the format that we are using is not appropriate according to the SQL. So we can add the values of this format only, as in the below example, because this is the format which is supported by SQL. But what if I want to add something, the value of like this? So what I can do is instead of giving the data type as date or timestamp, I can start by using the data type as string, and then can add my values of my own choice, and then can change the data type from string to date timestamp. So how we will be doing so? Let's see our example. So here I have created the same table with the data type string. And now I'll be inserting values that I want to insert. Now, as you can see that these are the string values, but I want to apply date and timestamp format for that. So I have to convert this data type from string to date time. So what I can use is I can make use of to underscore date or to underscore timestamp function to convert the values from string to date or from string to timestamp. So to underscore date is used to convert the values of column 1, uh, the data type of column 1 from string to date, and to underscore timestamp is used to convert the data type of column 2 from string to timestamp. And with a comma, we can specify the format that we want to insert inside it. Moving forward with the conditional functions. And so there are three type of conditional functions that we will be using: if, nested if, and case. So let's start with if. So the simple syntax of if is something like if this condition is specified, then it will return first value, else it will return the second value. Let's understand this through an example. Here as it is written that if trip duration is greater than 60, then it should return long, else it will return short or medium. So it will simply work with this condition. Wherever this condition is true, it is giving long, else it is giving short or medium. Now, just in the same way, we can make use of nested if. by applying another if statement inside the if statement. As in this example, we have done if this condition is true, then it will give the value as long, else it will solve this if condition and give the answer accordingly. And for this if condition, we have written if trip duration is greater than 30, then it must give the answer medium, else it will give the answer short. Now, instead of making use of nested if statement, we can get the same result by making use of case. So for that, the syntax is very simple. Case, when condition 1 is true, then it will return result 1. When condition 2 is true, then it will return result 2. And when condition n is true, then it will return result n. Else, a default result, and then n. Or you can write end as with the table name that you want, with the column name that you want to specify. So let's understand this through an example. So we will try to get the same result for the previous query that we got in the nested if. So we can write case when trip duration is greater than 60, then long. When trip duration is greater than 30, then medium. Else short, and as trip category. So the strip category is the name of column for which it will satisfy these three conditions. Moving forward with some aggregate functions. So there are some popular aggregate functions like sum, count, min, max, mean, etc. So we will make use of them. Now here, select sum trip duration. So it will give the summation of all the values inside the column trip duration. It will give all the average of the values inside trip duration. It this max strip underscore duration will give the maximum value which can be inside the strip underscore duration, and this minimum trip duration will give the minimum value that is present inside trip underscore duration. And for count, we will get the unique values, like unique number of values, how many unique ride IDs are there, or how many unique trip durations are there. Since these columns have all the unique values only, so it is returning the total number of rows that were present in our data set. Moving forward with the group by clause, so the group by statement groups rows that have same values into the summary rows. So these clauses are mainly used with aggregate functions. So let's understand through an example. Now let us suppose I want to uh, count the trip duration based on the ride ID. Like for a particular ride ID, what are the trip duration? What are the counts of the trip duration? Right, but this syntax is giving an error because we haven't made use of the group by clause. So to get the correct result, we should have written select ride ID, count trip duration from trip duration, group by the ride ID. So whatever the non-aggregate function is here, we should group by it through that, and then we will get the appropriate result. Moving forward without now it this group by clause can also be used for non-aggregate functions to get the unique values. So let's say this table that is group by demo. So it contains these columns, these four columns. Now if I want to fetch unique values inside member casual, then what I can do, either I can write select distinct from group by demo, or select distinct member underscore casual from group by demo, or I can make use of group by statement or group by clause to write select member underscore casual from group by demo, group by member underscore casual. So it will return the unique values which can be present inside member underscore casual. Now, for the aggregation function as done before, we can simply write select member casual, mean of trip duration. Now we want to get this mean according to the member underscore casual. So we will be writing group by member underscore casual. This was for one particular column. We can also do this for multiple columns like member underscore casual rideable type and then the aggregate column. Then we have to group by for both of the columns, member underscore casual and writable type. What if we do not do so? Let's see an example. Here we have written two non-aggregating aggregate functions, but we are trying to group by it for one non-aggregate functions. So in that case, it will give errors. So either we have to write member casual, comma, writable type, or we can also make use of indexing and can write 1, comma 2 instead of writing the complete name. Now let's move forward with having closed. So we can filter our aggregated tables by making use of having closed. So as done in this example, we had fetched member casual, maximum of prep duration, minimum of prep duration, group by it with member casual, but I want to specify a particular condition where member casual should be casual. So we can write having member casual is equal to casual. We can also obtain the result by using where clause, on which we can write select member casual, maximum of prep duration, minimum of prep duration, where member casual is equal to casual, and then group by with member casual. Now, since the result of both the syntax are same, but the way in which they are treated inside the SQL are different because of their order of precedence or the order of execution that we will be learning for in the future. But first of all, let's understand the difference between both of them. So for this particular statement, what we are doing is from this table, we are grouping by it through member casual, right? So first of all, first of all, from this table, this group by will take place. After grouping by, we will be this having statement as executed. So only those values which have casual as the member casual will be selected, and then the select function will take place. And in case of where, the first precedence will be given to from, so from this table, then where member casual is equal to casual, so it will move only for those value where member casual is casual, and then the group by statement will take place. In first condition, first group by is working and then the condition is applied, but in the second case, first the condition is applied and then the group by statement will take place. Moving forward with some other examples, like for the having clause, what we can do is we can also use aggregated functions in the having clause, which is not possible for the where clause, as here it is written having mean trip duration less than 100. This cannot be done for the where clause. Now let's understand the concept of joins. So what are join? Join keywords select the records that have matching values in both the tables. So there is a very simple syntax for join, that is select column name or column names from table 1, join table 2 on table 1 dot column underscore name is equal to table dot column underscore name. So basically what we will be doing is we will be joining two tables on the basis of a particular column in both the tables, which I specified here. So let's understand this through an example. As in this example, we have two tables. One is payment and one is goods. And I want to join them on the basis of good ID present in both of the tables. So what join will do is it will extract the common values or the common records inside both the tables and will give all the values of different column names. As we can see in the syntax, select star from payment as P. So from this payment, we are selecting all the columns, join good as G, and from this we are also selecting all the columns, and we are joining both of them with good ID, right? So for the payments, at first there is three, so the good ID is three. For three, the payment ID is one, amount is one, and for the value three, the good name is bread. So it will integrate the good name bread with these three values. For again 2, 4, 1. So for 4 there is milk. So it will integrate milk with it. For 7372, the value 7, it do not contain value 7 inside good underscore ID, so it will reject it and will move forward, and so on. The join syntax will take place. So applying this join on the tables that are inside the Databricks, which were bike data and station data. So we have written the simple syntax, select star from table 1, join table 2 on table 1 dot column name is equal to table 2 dot column name, and it will join all the columns accordingly. Moving forward with order by close. So what this order by do is it will arrange the records in a particular order, say ascending or descending, as specified by the user. If in case not specified, then by default it is ascending or it choose ascending format. As in the following example, we are selecting all the values from this particular table which are ordered by as start station ID as ascending and started at as descending, which means that all the records are in such a way that they are arranged in ascending order for start station ID. Like the values inside start station ID must be in ascending order, and for that the started at must be in descending order. As in the You can see in the following column, this is in ascending order. It is starting from 101, then we'll be moving forward with 102, 103. And for all those 101 values, these are in descending orders. The values are decreasing. Now is the limit clause. Now, if you want to view some particular number of records instead of all the records, so you can make use of limit clause by writing limit and the value up to which you want to limit your record. As in the following example, we have written limit 10. So it will show only 10 records. So there are 10 rows which are visible instead of all the records that it can fit. So as I had told you before, there is a order of precedence for the execution of these clauses. So the order of precedence is as follow. It starts from, then join, then where, then group by, then having, then select, then order by, and then limit. Now, to understand this order of execution, we will go through some queries. Let's move forward with that. Here it is written that select ride ID as row ID from this table, order by row ID. So, according to the order of precedence, this from will take place at first or is executed at first. So, from this table, we will select ride ID as row ID and then we'll order by it according to the row ID. So the order of precedence is 1, 2, and 3. So from this table, first of all, this column is selected and then this column is arranged in ascending order. Similarly, in this case, what is done is we are selecting row ID from this table where ride ID is there. So according to the order of precedence, from this table, those values are selected where ride ID is equal to this particular ID. And then ride ID is being selected. So the order of precedence is 1 for from, 2 for where, and 3 for select. So from this table, only these ride IDs are selected. Then what are the concept of subquery? So a subquery is essentially a query nested within another query, allowing users to perform operations that depend on result of some another query. So basically, these are the queries inside the queries. Let's understand it through an example. Here, as you can see, there are two queries, right? So this query will depend on the result of the second query. So from this table, where this particular condition is satisfied, we will be selecting all the columns. So first, let's understand the query inside this query, which is select distance start station ID from this table where date difference is greater than 1000. So at first, this query is solved, the result is obtained, and where the start station IDs are from these IDs, from them, these columns are selected. Now, what are view? So, view is a virtual table based on the result set of a SQL statement. So, views are extracted from the tables that we have created or that are present in the Databricks workspace. So, how we can create a view? To create a view, we can simply write create view, name of the view with the schema that we want our view to be inside, as select star from the table name from which we want to extract our view where a specified condition. We can see the view in same manner as we do for table by writing select star from name of the view, and we can also drop this view by writing drop view, name of the view. Now, there are some set operators like union, intersection, and except, which can be used in SQL. So, what are they? Let's understand them one by one. Let's start with union. So, for two sets, say 1 and 2, union is basically the values from first set as well as from second set. Okay, so it will contain the value which are inside first and the values which are inside second and the values which are inside both of them. For intersection, it will contain only the values which are inside either A or which are inside A and B both. And for the except, it will include the values which are inside either one of the set, excluding the second set. Let's understand them with the syntax. So for union, we are selecting all the columns from this particular table, which are ordered by started ID ascending limit 5. So there are two queries, first and second, and we are making union of both of them. It means that we will get result for this statement as well as for this statement. So it will give us the top five values for started ID and it will give us the last five values for the started ID. So total there are these 10 records which will satisfy both of these conditions or the first condition or the second condition. For the intersection, it will give us the common values for first as well as second condition. So the first condition will give us the values which are between these two timestamps. And for the second condition, it will give us the values between these two timestamps. And after applying the intersection between these two, it will give the common values which will be from 10 to 11. So the values inside started at are between 10 to 11 only. Sorry, from 11 to 12 only. Then for except, it will include the values for condition 1 after excluding the values from condition 2. So the condition 1 will give the result which contains timestamp from 10 to 12 and the second one will give the values from 11 to 19. So after excluding the results of second one, we will get the results that are from 10 to 11. So the started at column will contain the values which are from 10 to 11. Then there is a concept of delta lake, which we have already studied before. So what were delta lakes? Delta lakes were the betterment of data lakes with some reliability, structure, and flexibility. So these delta lake follows a medallion architecture and can perform last mile ETLs. There are some benefits of delta format which we will be learning now. And then what are these upsert or merge into commands? So let's start with the medallion architecture. So what is it? So it is a data design pattern that logically organizes data in our data lakehouse. There are three layers in this architecture, which are bronze, silver, and gold. These are increasing in structure and quality of the data. So this bronze layer is the ingestion layer which maintains the raw state of the data source. And the silver layer contains filtered, clean, and augmented layer. So the data from the bronze layer is filtered to convert it to the silver layer. And then is the gold layer where we have business level aggregates. So from the silver layer, the data is further cleaned. Some feature engineering is done and the gold layer is obtained. And then is the last mile ETL, that is extract, transform, and load. So from the gold layer, the data is we extract the values from the data, and small changes are made to the gold layer to perform ETL. Then are the benefits of the data format. So here are the following benefits. First one is the asset transition, that is atomicity, consistency, isolation, and durability. Then is the schema enforcement, which can modify data structure without breaking existing data. For example, we can add new columns to pre-existing tables. Then it also supports TML operations that allows to modify data directly in the data lake. It can also audit history. Data Lake automatically tracks changes to data, providing comprehensive audit history. It also supports time travel by allowing to access and analyze data at different points of time. And then they have optimized performance. They support unified batch processing and streaming. And Data Lake is an open source project. And then coming to the merge into. So what are the merge statement? It compares data between a source table and a target table based on some specified key field and performs some appropriate actions like insert, delete, and so on. So let's understand its syntax first. So there are two tables, a target table and source table. So we will merge into the target table using source table on merge condition. When matched, then update set. Column 1 is equal to value 1 or column 2 equal to value 2, column 3 equal to value 3 and so on. And when not matched, then insert column 1, column 2, column 3 up to column n, values value 1, value 2, value 3 up to value n. Let's understand this through an example. Let us suppose there is a table, say target table, which looks like this, and a source table, which looks like this. So now I want to merge the values of the source table into the target table and update the values according to the source table for those fields which are same. Okay, as in this case, this zone contains has the age 30, but for the updated field, it should have age 20. So it should update the value 20 here, and this row is not present here, so it should be inserted. So we will be simply writing merge into target table as T using source table as S on T.id is equal to S.id, which is the specified condition. When matched, just in case of John, when matched, update set star. So here the values are being matched, so it should update the values. And when not matched, then insert star. And in this case, the values are not matched. Sorry, in this case, the values are not matched, so it should get insert on that table. And then we will view the merge table, which will be like this. Now, what is query caching? So, caching is a process of persisting intermediate data or the result of computation in memory or in disk. It is an optimization technique used to speed up the execution of queries and transformations on the large data set. There are different types of query caching as can be seen here. At first is the UI cache. When users first open a dashboard or SQL query, the Databricks-SQL UI cache displays the most recent query result, including results from the scheduled execution. And the lifetime of this UI cache is 7 days. Then are the local cache, which are the in-memory caches that store results in SQL warehouses, and they have a life cycle of 24 hours. And then are the remote caches, which are available on serverless SQL warehouse only, and it's a cache system that retain query results by persisting them in cloud storage, and they also have a life cycle of 24 hours. Then are the disk caches, which are also known as delta caches. They can be stored on disk, allowing for accelerated data rates, and data is automatically cached when files are fetched utilizing fast intermediate format. This was all for today. Thank you very much.